time, so I'm going to introduce George, and you got it from here. Cool. Thank you very much.
Thanks for having me. Like a set of bar stock set up.
I do.
Little lathe turning today? Oh, that's the first joke. First joke fell on his face. More coffee. Okay. All right. We're going to do 3 different types of drawer joinery today. And a couple things. We're going to do everything we can to make what I'm doing visible so that you can see kind of the minutia of the setup. There are going to be a lot of detail-oriented things that it's important for you to see. And you're recording this, right? So you can always come back and see it again. But if as we go, there's anything that isn't as clear as you need it to be, just stop me and we'll come back to it. It's a lot easier to answer questions while we're in the middle of it than it is to get to the end and come back and try to duplicate a setup. So yeah, stop me anywhere along the way. The 3 things that we're going to do are rabbet joints, and then a lock rabbet joint, and we'll have a look at that. It goes by a couple different names, and then a drawer lock bit. So we're getting increasing difficulty as we work toward the drawer lock bit. Let's talk about material first. So this stuff is called what? Wood. Wood. Is it called wood? Another smart ass in the group. Thank you. Besides me, yeah, it's Baltic birch. So, but calling this Baltic birch is kind of like calling all facial tissue Kleenex, right? What's the real name of this as plywood? Yep, we're getting closer. It is pre-finished, which is really nice. It's a cool product. So what this is really called is multi-ply plywood. So if you go to Home Depot and you buy 3/4 inch oak veneered plywood, it's not going to look like this. This part being the significant number of plies in the material. Part of the reason I'm harping on this is that this stuff is a wonderful drawer material. I use it for drawer boxes all the time. There are some promises with multi-ply plywood that you don't get from other materials. One is that it has a lot of plies. So in 3/4 inch material, there are, I think, 13 plies in 3/4 inch multi-ply, 3/4 inch Baltic birch. If you just buy 3/4 inch standard plywood, it's probably got 7 plies. So one of the things we get from that, from having more plies, is a more stable material. So man-made materials in general are more stable than solid woods. Multi-ply specifically is more stable than standard plywood. So Baltic birch is the name we know the most. There's another one. Anybody know what the other one is? It's also a multi-ply. Yeah, apple ply. So the deal is that Baltic birch, if you're specifically getting Baltic birch plywood, it's called that because it comes from the Baltic region of the Soviet Union. That's why it's Baltic birch plywood. Apple ply is domestically made. So there's a couple things that are important to understand. If it is in fact Baltic birch plywood, Baltic birch is a metric product, not an imperial product. So when we call this 1/2 inch, it's not really 1/2 inch plywood, it's 12 millimeter plywood. And I'd have to do the math in my head. 25.4 millimeters is an inch, so whatever half of that is actually a 1/2 inch. So the deal with that is that when we work with this, it's a little bit undersized. 12 millimeters is less than a 1/2 inch. 19 millimeters, what we call 3/4 inch, is less than 3/4 of an inch. So for what we're going to do with our drawers today, it doesn't have a huge impact on us, but I've built toolboxes on Baltic birch plywood. And if you're going to cut a dado, that the 3/4, 19 millimeter stuff is going to go into, it takes some fussing to get it to fit just right because it's undersized material. Go ahead.
Is apple pie as good as Baltic?
Yep. So comparatively, well, let's do one other thing and then we'll circle back to that. So when you go by Baltic birch, what's the other thing that's funky about it? So its thickness is dimensionally one thing that's weird. What's the other dimensional weirdicity?
Weird shape. It's weird size.
Yeah, it's 60 by 60. Don't ask me why. but the sheets come 5x5 instead of 4x8. Apple ply is 3/4 inch, if that's what we're buying, 4x8 sheets. Comparatively between the two, I could put either one in front of you and you wouldn't know which one you're dealing with. They're identical, except for, oddly, when you write the check to buy them. Apple ply costs me about 50% more. You know, in the world of weirdness, the domestically made product is about 50% more than the imported product per square foot. So as material go, they're the same product. But if loading it in your truck is a deal, the 4x8s, of course, are easier to handle than the 60x60s. Even just for me carrying the Baltic around my shop, it's all I can do to pick up a 60x60 sheet, just from a wingspan perspective, and move it around. The other promise that we get out of it is that multiply plywood never has internal voids. So when we use this for drawer boxes, it's nice because when you cut into it, you don't end up with these pockets that you often have in other plywood. Depending on what grade you buy, part of the football in this one. So this right here, that little piece of a football, that's a plug that was cut in there to get rid of a defect. So I'm a little foggy on this. I think it's like double B, triple B. You're welcome to correct me if you know it. And one of those grades might have footballs 2 sides, and then one of those grades I think only has footballs 1 side. I don't think you can not get footballs. But it's depending on what grade you get, it'll show up on both faces or a single face. The other thing that I like about it is that I'll pass one of these around. When I pass it around, look at the plies, and the big difference, a significant difference between this and other plywoods is that all the plies, including the face veneers, are the same thickness. So, has anybody ever sanded through a veneer on a ply? Today's, on like oak veneered plywood, that veneer today is about a 1/24 of an inch thick. You'll be pleased to know they're working on equipment that will let them make it thinner. They're shooting for a 42nd of an inch if they can hit it. So when you're working with that stuff, I mean, if you look at it funny, you go through the veneer, right? And if I buy oak plywood, is it oak inside? Is the core of the plywood also oak? Yeah, no, it's some secondary material. It's popple or cottonwood or something. So when you sand through the oak or the walnut or the birch, whatever's on the face, you're looking at something that totally does not match what you just sanded through. So one of the things that's nice with the multiply is that the plies on the face are thicker. Thicker to the extent that I cut a lot of this on my CNC machines, and I'll send it through my surface sander to clean up the faces after it comes off the CNC. You got to be a little bit careful because you can sand the face when you're off. But there's enough meat there that you can actually work with it and send it through a drum sander after the CNC work to clean it up. So again, the apple ply Baltic birch, same product except for price. No internal voids. Great drawer box material. I do not edge band the top of the drawer boxes when I'm done. What I find is that if I make drawers out of this and you sand that edge and then you put a finish on there, most people like how that looks. And they think like, how did you make all those cool stripes and so Can't tell you. Can't tell you. Tracy. So, and especially when we look at the drawer lock bit and the lock rabbit, when those parts interlock at the corner, it adds another kind of cool gee whiz to it. That you get that sanded nice, you get a coat of finish on there, and it looks good. So I don't go to any extra step to try to cover that plywood edge. Questions so far? And among the plies, or among the material available, 1/2 inch is what I always use for drawer boxes. Okay?
Excuse me, how expensive is this? I've never bought
I pay $19, I don't know here, I pay $19 for 1/2 inch 5x5s where I live.
$85.
No. It's about.
Well, thanks to Proposition 65.
Don't eat it, it'll cause cancer.
Yeah, does anybody know what a,
It's approximately, I think it's $22 a teach, maybe something like
And Rockler sells it, but they sell it like in handy panels. I mean, I don't know that your Rockler sells it, but I know the Rockler stores by me carry it. And it's because it's been cut to handy panel sizes, it's more per square foot, but it's available there if you just need a sheet or two.
Two cuts and sheets for free. So, and they got a nice panel saw they cut it pretty straight and accurate.
And it's not, this is not a home center thing. Like, so by me, there's a home center called Menards, which is like a Home Depot. They sell a multi-ply plywood, sort of, but like a lot of home center things, it's been dumbed down. So it's nowhere near the same material as I would get from a hardwood specialty place that's actually selling apple ply or plywood. One of the coolest things, somewhere I have a picture of it, I ordered a unit of Baltic birch at one time, 33 sheets. So when it came, it was still in the bundle that it came overseas from, and there was plywood on all four sides, one of which was stamped "Made in Russia." So I wanted to keep that piece of plywood, and it accidentally got thrown out. But it was cool, just that it really is made in Russia. First time I'd seen it.
Does all the Baltic birch really come from the Baltic, or does some of them come from China now?
I don't know for sure.
It's not radioactive. The commie ply. Yeah.
From the Chernobyl area of Russia.
Does anybody notice CH&H apple pie?
Yes, they do. Yes, they do. Well, a lot of the lumber sellers call it as 11-inch wide pieces already with bulldoze on both ends. And use that. You can build it 9, 11, and 5 or 6. And you can cut it and make 2 drawers out of it. So that's what I use. You can buy it in 60-inch lengths, already bulldozed and pre-finished on the edges. So you make a drawer.
So if it's a 60-inch length, it's probably Baltic, not apple ply. So does anybody know? Which store did you ask? CH&H? TH&H sell apple ply?
Yes.
Yes.
So it's Ross, I guess. Ross sells both.
Okay. Other questions before we jump into a joint? This being California.
It's in California.
I love the no smoking sign in my hotel room. It's got an X through a cigarette and a marijuana leaf. Just in case you weren't sure on what smoking really
Is that hourly rate at that place?
is. It's somebody here recommended it. All right. Rabbit joint is the easy one. It's low hanging fruit. We'll do that one first. If I was a drag race, I'd do it. Okay. So rabbit joints are crazy simple. All we're going to do is in the Baltic, we're going to make a cut that ends up looking like that. And then another piece is going to end up fitting into there like that. And then we would have another piece over here. Eventually, it looks like that. Are the vertical pieces in this drawing the drawer sides or the drawer front and back? Sides. Let me ask again. Are the vertical pieces of this drawing the sides? So here's the way to think about drawers. We want to get this, we want to make a drawer box, and this is dovetails or what we're doing today. We want to make the drawer box such that it's as hard as possible to pull the front and the back off. So traditionally, this would be your front, and then there'd be another piece here. This would be a side, and this would be a side. With the thinking being that if we glue this together, and maybe there's a mechanical fastener that comes in from the outside, that we've made it hard for this piece to pull free of those rabbets. So the rabbit joint that we're about to cut, we would cut into the drawer sides. And we'll do the same exercise with each of the joints that we're going to create.
George, why is it any easier to pull it one way than the other?
Because I said so. In the case of the rabbit joint, it's probably not significant mechanical. I mean, there's no mechanical grab here, like there will be on the next two. So I would say, in this case, I would attribute this more to this is the way drawers are commonly made. And not, and I mean, you're right. When we glue this together, if we did some kind of a fracture test on this, would it take more PSI to do this than to do this? I don't really know for sure. But typically, this is how drawer boxes get put together: is you rabbet the sides and you make the front and the back.
To compensate for that, I use a little Miller dowels on the sides and come in on the sides on all my drawers, especially towards the top, because it's a single one wall, so that you can't pull them off.
To get another
And that makes
plug
them
in there.
That makes them bulletproof.
Miller dowels are cool products. We can do all of the work. Oh, go ahead.
Is there any advantage of doing a double rabbit for, so I've seen somewhere they do a rabbit also on the front side as well. So,
Well, that's kind of what that is what we're gonna do on the second joint. Yeah, lock rabbet. We can do this whole joint with just a regular straight bit. What I like to do when I can is have the diameter of the bit larger than the thickness of the material I'm cutting. And I just find that makes the setup a little bit easier. So it's not imperative. And because we're in Baltic birch, so the real thickness of that material is probably 0.423, which I only know because I use it on the CNC all the time, and you have to know exactly how thick stuff is on the CNC. So if we had a 1/2-inch cutter, that would be fine for our 0.423 Baltic birch. But I like that diameter to be a little bit bigger than the material. Just in the world in general of router bits, this Freud straight bit is going to do a great job on this. What's the benefit to a spiral cutter, a spiral router bit?
What's the material that removes chips?
Okay, maybe, so we have to get more specific, and we'll talk about that.
Less tear out.
Less tear out. So did you get a helical head on your jointer?
yes.
Okay.
Yes.
So it's the same concept. You know, people are all agog about helical heads on jointers, helical heads on planers. So if you were ever taught to use a hand plane, someone might have said, when you're getting down to your last pass, skew the hand plane just a little bit and make that pass, and then you get a better shear cut by running it a diagonal like that. So when we're spinning this thing at 24,000 RPM, and it's a spiral, it's the same idea. Instead of attacking the wood straight and kind of hammering at it, we're shearing with that spiral. But then, because of the other answers we got, we need to take it a step further, because there's two kinds of spirals, which are what? Upcut and downcut. So in my shop, probably 90% of my spirals are upcuts and 10% are downcuts. So if the flutes on the bit look exactly like a drill bit, in other words, they go in the same direction as a drill bit, it's an upcut. And it can get confusing because router table, handheld router. So a handheld router, it looks like an upcut. Router table, it's pulling down. But the benefit to an upcut is it'll evacuate the dust out of the joint. For the rabbet joint we're doing here, that's not a big deal. Where would it be a big deal? What joint? Dado and or mortise. Really big deal. You know, generally mortises are pretty deep. So it's a big benefit on a mortise joint. It's a big benefit on a CNC machine where we want to evacuate the dust out of it. But for what we're doing here, the straight flutes are going to be fine. So if I want to, okay, we are unplugified. Right? Anytime you're doing setup changes on your on any tool, you want to make sure you're unplugged, and then we'll get the router bit in here. So when you put a router in, let's come in, Lou, on the bit. If you would. When you put a router bit in, we don't want it in too far, and we don't want it in not far enough. So the deal with too far is that if you look really closely at the way a router bit is made, there's generally, you have a pencil? This should disappoint you. There's typically a fillet where the shank of the router bit meets the body of the router bit. So if you look right there, there's a little transition. And if I push that down into the collet, what can happen is that the top of the collet is trying to grab that slightly oversized transition instead of the nicely machined shank of the router bit. that could lead to it coming loose later, because you tighten it, but that red band right there is a few thousandths bigger than the silver part below it. So it's not really as tight, it's not as snug as it could be. So that's why we don't want to just push that down and tighten. We want to pull that up a little bit. The other thing out of that is that the way collets work is that they squeeze and they pull down. So if you're already bottomed out, then you don't get or you may not get a pull down. So you're not letting the collet do everything it should do. At the other end of that just scares me just looking at it. I can't imagine a router bit coming loose at 24,000 RPM, but I don't think it would be good. So a good general rule is about 2/3 of the shank in the collet is going to keep you safe. Then, for tightening, if your knuckles are turning white, you're tightening this more than you need to. Same on a table saw blade. We need this to be good and snug, but we don't need to come along on there, squeezing this in there. If you're using a hammer to tap wrenches to get stuff apart, you're putting it in too tight. So once we get this snug right there, I'm happy with that. Right there, that's done. Given the opportunity, when you're buying router bits, 1/2-inch shank versus 1/4-inch shank, default to 1/2-inch whenever you can. So some routers that doesn't work for, like, so what router doesn't even have a 1/2-inch collet with it? What type of router? You got trim routers, all you're going to get is a 1/4-inch collet. That's all they got. But anytime you can use a 1/2-inch shank, you should, for a couple reasons. Bigger shank, less chatter in your cut. Not a deal for what we're doing today, but you talk about making doors where you've got big beefy cuts, you're taking a lot of wood off at one time, chatter can be a thing. The other thing is, I can never remember the geometry, when we double the diameter, the circumference, I think, quadruples or eightuples, one of those two. So there's a lot more surface area between the collet and the shank on a 1/2-inch bit than there is on a 1/4-inch bit. And for the most part, you find there's little, if any, price difference between a 1/4-inch roundover bit that's a 1/2-inch shank and a 1/4-inch roundover bit that's a 1/4-inch shank. So default to 1/2-inch shank whenever you can.
George, do you have a preferred length of your straight bit?
Most of I use this particular Freud cutter all the time. A 1-inch cut length is pretty versatile. I've got a couple that are longer. Those are actually spiral cutters that are specifically for real deep mortises. I think I've got a CMT spiral cutter that's got a cut length of a couple inches on it. Doesn't get used very often. That 1 inch is pretty versatile. All right. If you don't yet own gauge blocks, what's wrong with you? You should. One of the things that I do in my woodworking all the time is I avoid measuring at every cost. Whatever I can do to not measure, I will do. So gauge blocks are an example of that. Transferring measurement is an example of that. If you've watched cabinet making videos, I'll make an entire face frame without ever using a ruler, because we just transfer all the dimensions from the case of the cabinet to the face frame. And at the end of the day, I don't care how big the face frame is, but it's really important that it covers the case. So doing it that way, I know I'm going to get that. So with gauge blocks, these are wonderful things. And for me, I think it's a throwback to my machine shop days when I was doing metalworking, because in a tool and die type environment, you gauge so many different things to get accurate setup. So here, what I find with gauge blocks is it makes it easier to do the setup, and it gives me better repeatability. If I measure the height of this bit to a ruler, I love my folding ruler, I use it all the time, but if I measure it with a ruler, and then have to come back and do that again, versus set it to a gauge block and have to come back and do that again, I'm more likely to get it right the second time off a gauge block. Something like a plunge router, you're setting depth for a 1/4 inch cut. The easiest way to do that is to use a gauge block in between the stop rod and the turret. Drill press, dado head, there's a billion different ways to use gauge blocks. So for us, when we make this joint, General rule of thumb is the depth of a rabbet is half the thickness of your material. And I'll give you a qualifier for that in a second. If I'm doing a drawer box, that's the rule I'm going to use. It's half the thickness. Now, a couple minutes ago I said this Baltic birch is probably 0.423, so our rabbet should be 0.21015. You already know enough about me that ain't going to happen. 0.250 is going to be plenty close. So don't pull your hair out trying to get exactly half. We can call this half-inch plywood, so we can call this a quarter-inch rabbet. That's going to be fine. The exception to this rule comes in cabinet making, and a rabbet joint is very, very common in cabinet construction. So the rule is half, which is what we're going to do, half the thickness, or 1/3 the thickness. The 1/3 the thickness will come into play if you're building a cabinet that has, it's such a big cabinet. That's the deck, or bottom. And it's such a big cabinet that here we have a mid-wall. Or what some people call a party wall, because that's a cool name. So if I have a mid-wall, and I cut a dado halfway in from one side and then halfway in from the other side, that could be a bad thing. So in this case, where you have a mid-wall, then this is where you go to the 1/3 the thickness instead of 1/2 the thickness. All right, here's how it comes into play for what we're doing. This router table has a router lift in it, which is cool, but you don't have to have a router lift to do anything that we're doing here. It's going to be really, really nice when we get to the drawer lock bit that we have a router lift, because their tiny adjustments are the difference between a good fit and a bad fit. But I've cut these joints bazillions of times by reaching under the table and adjusting a motor. So it can be done without a router. When the insert goes in, you want to keep, obviously there's one distinct way for that to go. You want to keep the hole in the insert as close as possible to the diameter of the cutter. That's a safety thing, so that stuff can't get caught down in that hole. Then, take your bar stock. Says. Lay that on the table. And this is a thing that's easier to feel than it is to see. So I'll just run my finger across the top of this, and I'm feeling top of the carbide, top of the bar stock. So I went below, and now I'm coming up. Right there. Now here's the deal. A thing that I try really hard to teach in my classes is consistency is typically more important than accuracy. So what does that mean? Once this is set, I want to have all my drawer stock ready to go. Maybe this is a 1/4 inch, maybe it isn't. But if I'm making drawers, and they're going to go on full extension slides, which means I'm going to have a cabinet, metal slides, can't send those through the surface sander to readjust them, metal slides, and then a drawer box. That drawer box has to be exactly the right size. So it's critical that when this rabbet is cut, and that's my drawer side, that I know what that dimension is. So I can dimension the drawer accurately. I need every one of my drawers to be the same size. So I'm not worried about doing a test cut here. Feeling this tells me, I think we're at a 1/4 inch. I'm then going to make all my drawer boxes using this for my rabbet joint. And I want to make sure I have all the parts ready so that I can do all the drawer boxes at this stage. So that's a plan your work and work your plan part of woodworking. So that we don't have to come back and duplicate a setup. It's gonna happen every once in a while, but you really should go to great lengths to try to not have to do something twice. Because we're humans, and you may or may not get this identical.
So you make your drawers first, or before you make the cabinets?
No, always cabinets first. Cabinets. So for me, cabinet making is start at the wall and come forward.
Okay.
So start at the wall is how big does the cabinet have to be? Then I build the case. Not until the case is done do I do the face frame. Not until the face frame is done do I do drawer boxes and doors. So everything is moving front to back. And so other cabinet makers will do face frame and then build the case behind it and the drawers and the doors in front of it. That's wrong. No, it's different. Many ways to skin the woodworking cat. It's just a different way to do it. But for me, I bring all my dimensions off the case forward. Okay, height of the router bit is right. I find on most of these router lifts, you don't have to lock this, but I don't know, I will. Just because the mechanism is good enough, they just hang there. So height is right. What's the other thing we got to set now? Got to set the fence. So what we know, I can do a little of this too to make your life easier. Well, this has to come way. The dust collection. I guess we're not using the dust collection, so let's do that. All right. So keep the hole, or the insert in the table as close as you can to the diameter of the cutter. Keep the hole in the fence as close as you can to the diameter of the cutter. 1, safety. 2, you'll get better dust collection if you're funneling that opening down instead of leaving it huge. Here's what we know. This material is some thickness, right? Like 0.4, whatever it is. So at this stage of the game, what I could do is get a ruler out and then try to find on my handy dandy folding ruler 0.423, and all right, you're figuring out that ain't gonna happen with me. So instead, I'm gonna take my drawer front, which that's what the rabbit has to fit, and do this. And I'm gonna gauge the position of that fence. So let's go, I'm gonna spin this just a little bit. So gauging the position, and I do this exact same thing on a table saw with the dado head. When I'm gonna cut rabbits for case, rabbits in case sides for the top. I bring this fence over until that carbide is a fingernail catch past the face of the piece. So it's in dimensions, it's probably a 32nd of an inch or so. But like setting the height of the bit, this is easier to feel than it is to see. Now what's critical about the bit position right now? Or the bit rotation? Yeah, I've got to be at what in like automotive we would call top dead center. So I've got to have this turned so that that carbide wing is at its maximum circumference away from the fence. Then, the other thing that'll make my life easier is lock one end of your router table fence. So now we're just pivoting on the other end, and that makes it easier to micro adjust. Then, bring the material in, mess with this end until I can feel that fingernail catch. By leaving that fingernail catch, what's that doing when I cut the rabbit? Making it too what? Too wide. We're making a rabbit bigger than the material that we're working with. I'm doing that on purpose. So I will, just trust me on that, and if I forget to say this, remind me that I was going to say it. And I think it's easier once we have one cut to talk about why I do that than to explain it. With me so far? We're going to make chips. Do you mandate everybody puts on in the audience safety glasses and ears when we do this, or is it just every person for themselves?
Well, no, we do normally.
So if you're going to do hearing protection, this would be the time to procure it. because we're about to make a cut.
No.
So, a few years ago, I don't know why I went, but I went to get my hearing checked. And they said, oh, yeah, well, there is a problem. Your hearing's okay, but you're going to have a hard time hearing high noises like women and children's voices. The problem being... Okay. Now, if I was electricity...
Over here. Give me the cord.
So, sure, what's the worst that could happen? Do we have... Okay, we don't, that's okay. So what's the other thing that's really important when you're using a router, handheld or in a router table, the other big setup thing that you need to pay attention to, something on the router itself? Well, feed direction, we'll talk about that, the router itself. Yeah, on-off switch. So if you have a router table, you need an external switch. Don't rely on reaching under the table to turn it on. Speed, somebody said, that's a big deal. So with this 3/4 inch bit, we can easily run full bore. We can easily, this is a Porter cable 7518 in here. Top speed is 23 or 24,000 RPM, that's fine. When we get to larger diameter bits, diameter goes up, speed goes down. So you need to have a router bit speed chart in your shop. And we have one online. If like the club ever wants to just, you're welcome to print it out and as many as you want. But you really have to pay attention to that. If you put a panel, 3.5 inch diameter panel raising in this panel raiser in this machine and turn it on at 23,000 RPM, it sounds like a helicopter is trying to land on your shop, and it's crazy dangerous. You can't run it that fast.
For ply, it might not apply, but are there different speeds that are better for different types of woods?
Yeah, to some extent. So, like changing speed on a 1/4 inch roundover because I'm in hard maple versus pine. For me, I'm probably not going to do that because I don't see that much of a gain. But one of the things I've learned from using the CNC so much is this whole idea of chip load. And that does affect you with handheld and router table work as well. So I would say it's more likely that if I get into a real hardwood that I'm going to do a mortise in. So like a mortise and hard maple versus a mortise and pine, then I might lower the RPM so that the bit has more opportunity to cut instead of rub. And it took me a while to wrap my brain around this. Like, you've got these really sharp flutes. How can it possibly just be rubbing? And again, my CNC work is what really taught me this, and then changed my handheld and router table work. So when you get into hard materials like that, it can be a benefit to lower the RPM so that your feed rate stays the same, but you get the right chip size out of the mortise.
So what speed do you typically use on your CNC for the router?
Well, it depends. So when I'm cutting Baltic birch with a 1/4 inch bit, I run that at 12,000 RPM and 100 inches a minute. 3/8 bit, 16,000 RPM, 100 inches a minute.
Just to get a big chip load.
And then brass and aluminum, that kind of stuff, that's a whole different. The feed on brass and aluminum is like 40 feet a minute, and I gotta think a second, 18,000 RPM. The way to do this on a CNC is, don't listen to me. Go online, G-Wizard is a chip load calculator, and you put in how many flutes the bit has, what you're cutting, and it gives you numbers. And it's all been figured out. It's a subscription-based service. You can use it 30 days for free, and then it's subscription-based after that. But if you're using a CNC a lot, it's worth having.
We have it on our CNC.
Oh, there you go. You don't need to subscribe. It's been done for you. Okay, so when we make this cut, I'm going to take just a piece of scrap, another drawer piece.
Actually, there's some scrap in there with smaller pieces.
Oh, okay. Because I want to back this up. Anytime we exit with a router bit, there's a good chance we're going to get blowout chipping. So I'm going to back that up with a piece of scrap. Somebody mentioned feed direction earlier. This is a really big deal. you will always on a router table feed right to left when you live in the northern hemisphere. Even in Australia, they feed right to left. We're always going to feed right to left. The rule with cutting tools is you want to work against the direction of rotation. So you do this all the time and you don't really think about it. You stand at a table saw and you feed from the operator side, the blade's turning toward you. You stand at a joiner and you feed over the cutter head, the cutter's turning toward you. So same thing here. If we go in the wrong direction, and on those tools, they don't really give you the opportunity to go the wrong way. You can't. Here, possibly you could. If you climb cut on a router table, it's going to grab it and throw it. And if it throws it and pulls your fingers in, that's going to be really bad. So right to left. And then the other good router table rule is you're always going to bury part of the bit inside the fence. So you're never going to set this up such that you're routing with a piece of wood between the fence and the cutter. Now, if we're doing a dado on the router table, that's not what I mean. What I'm saying is, like, if you're doing an edge profile, you would never have the bit here and the fence here feeding the material in between the two. Okay, here we go.
On its low RPM right now.
Okay, so then our test is to do this and put the material in the rabbet and see what we get. So I would do this test cut first to make sure that we're getting what we want before I cut my real drawer box pieces. So we have a couple things going on here. One part of the test is we want to be 1/4 inch deep. The easiest way to check that is to just lay the bar stock in the joint. Same thing I do with dados, Daddy-O. I just lay the bar stock in there. Then feel across the top. If those are flush, your depth is good. Our other test is to put the material in the joint. And what we're going to get from this, and I'll pass this around, is there's a little bit of a lip right there because we intentionally cut the rabbet too wide. See how I roll you into this? We intentionally cut the rabbet too wide. We screwed this up really bad. No. We intentionally cut the rabbet too wide. So here's the deal. Another crazy thing with my woodworking. There's lots of opportunities to make mistakes. Given the opportunity, I want to make the mistake intentionally that I know I can fix. So here, one of three things is going to happen. If I cut this absolutely perfectly, this end will be perfectly flush with this face. This end will be perfectly flush with this face. That would be great. It would require me standing here and doing test cuts at the router table for like half an hour to get that just right. And then woodworking being woodworking, I don't really know why, not every piece you cut is going to come out perfectly. And if we end up with one mistake, which is the face of this piece past the end of this, not a big deal, we just sand this down, right? So a couple problems with the sanding idea. One, it's sanding, who wants to do that? Two, with veneer on plywood being thin, you've only got so much sanding room you can do here to flush it up. Three, it's not just sand this corner to make it flush, it's sand the entire face of that piece. So one, they come out flush. Two, the face of the front projects past the end of the side. I don't want that. Three, the end of the side projects past the face of the front. That's what I want. Because this I can fix really easily. So what's a solution for this? I glue these together, and then what could I do to flush these up?
Flush trim bit.
Who said sand? You might have to leave. The S word. Hand playing, I'm not a hand tool guy, but it could work. For me, it's going to be a flush trim router bit. So we glue this together. After the glue is dry, and this could be a cabinet, and I'm doing the exact same thing. After the glue is dry, flush trim router bit, the bearing rides here, the carbide takes off whatever sticks past this face, and it looks like you made it perfect right from the start. So it's a much simpler way to put these components together.
That means you gotta build all your calculations into the fact that you're overdoing it.
Yes and no. It's a 32nd of an inch. So when I'm doing a case set, if I'm building kitchen uppers and they're 30 inches tall, I don't make them 30 in a 32nd. Because, why? What did I say like half an hour ago? Consistency is more important than accuracy. So when I do my uppers, they all get treated the same way, and I hang them on the wall. And the only, we as woodworkers are going to say, well, they were supposed to be 30, but they're actually 29 and 31 32nds because I did this flush trim thing. And then nobody's going to know. So here on a drawer side, if you're using mechanical slides and they're 16-inch slides, and you cut this drawer side to 16, which is what I would do, and it's now 15 and 31 32nds, you're still going to be fine. So it's a great question, but dimensionally I'm not incorporating the anticipation of this trim into the dimensions of what I'm making. I just let it go.
So you cut your fronts and your back 16 inches.
For well, not fronts and backs.
I mean,
sides. The size of the slide is the length of my side.
Right.
Yep. And here's, so for me, with my woodworking, one of the things I did for quite a while was run a commercial cabinet shop. I was production manager of a commercial cabinet shop. And we built all the Old Navy stores east of the Mississippi, and every Banana Republic store in the country came out of our shop. So I had 13 guys under me, and 13 men and women under me in the shop. We were doing 1.5 million in trade a year. So techniques that would let us push stuff out the door accurately, well, quickly, and solidly became really, really critical. So a lot of what I do in my woodworking today is a byproduct of streamlining those processes and getting stuff to work well in that kind of environment, and then translate it into the woodworking I do today. So when I'm, still in my shop, I'm doing a onesie-twosie kitchen for somebody, I incorporate those same kind of techniques. So that's where that kind of thing, part of where that kind of thing comes from. All right, we went rabbit hunting and we were successful. The way that is, so I wouldn't do any tweaks here, and we'd be ready to go with all of our drawers, and we're set to cut all the rabbits.
So I got a question on,
Yep.
on the front and back then, you're not cutting those at all?
No, so you don't do anything to the front and the back. Now, here's what's critical. Let's do this.
So how's the glue work? Does the glue stick if they're pre-finished?
Well, even with this pre-finished, I think you'd still be okay because you have so much raw wood here, and you have raw wood on the end of this. So you're still going to get a good bond out of this. It'd be better if this was also raw, and then we could get a little glue against that shoulder to do this. But you're going to get enough of a bond this way between those two surfaces that you'd be okay. But dimensionally, we need to talk about something. So let me do. You have digital calipers. Let me cut one more piece. But the other thing that's critical here is that mechanical slides are very unforgiving. So typically full extension slides take up a ½ inch per side. So the drawer box you make needs to be 1 inch less than the opening it's going to fit into. If the drawer box ends up a tiny bit too big, you're in a world of hurt. Because you've got these metal slides. That was my joke about running them through the sander. They are what they are. They're a ½ inch. So everything needs to come from the way you make the drawer box. It's okay for the drawer box to be a little bit too small. It's not okay for the drawer box to be a little bit too big. As a general rule, I shoot for my box to be a 1/16 of an inch less than what the opening calls for. So what I was, where are we waiting? Is he?
Digital calipers.
Oh, they came. Never mind. Okay. So the reason I cut a second joint is at this stage of the game, what we need to do, now we know how big the drawer box is going to be. So we measure the opening. The opening is 16 wide. Minus the slides, that's 15, I think. Yep. So minus the slides is 15, but to calculate the front and the back, you have to cut a joint first. Then I'm going to take these two pieces and do this. And digital calipers are the best thing since electricity. Digital fractional calculators. And I'm going to measure across that combined thickness. Because now it's 15 minus 27/64. Yuck. But it's 15 minus 27/64 is the length of your front and back. So fractional digital calipers are good. Fractional calculator is maybe even better. Calculated Industries makes a really good one, inexpensive. You can buy it at Home Depot for 15 bucks. And it'll let you can plug in 15 inches minus 27/64, so it'll give you the answer. So that's the length of our front and back. And remember, then I would take another 16th off of that, because we want the drawer box to be a little too small. When you look at drawer slides, there's where you're going to drive the screw through the case component into the case. It's like a leaf spring. So there's a piece of metal there that's got usually 3 holes in it. You want to use the hole that's closest to the end. And then what that lets when the screw is here, and that tab looks just like this, then the body of the slide can flex away from the case side. That's why they're made that way. And that's how you get away with the drawer box being a 16th smaller than the opening calls for.
Is there a particular drawer slides that you like?
Accurite. I've used a lot of Liberty stuff recently. I get that on Amazon. It's an inexpensive slide, but it's been working well. I really like I've fallen in love with self-closing slides. They're so cool. You get to like the last inch of travel and they just
Like a blue motion one?
yeah. Yeah, Heffley is good. It's just that slides are so stinking expensive, and that's how I ended up at the Liberties, is because they're quite a bit less expensive than Bloom or Heffley or Nabgoid. But those are all good slides. Just one more. We're talking about drawers and slides. I don't know if I can draw this or not. So I'm not a huge fan of, I don't know, calculating, I guess, when I can avoid it. So imagine, so we build a cabinet, face frame, style, face frame rail, face frame style. This rail defines our drawer box, which in kitchen cabinets, this is usually 5 inches. So now we're to a point where we know the opening. So we did my work from the wall thing, start at the wall. We built the case, we made the face frame, we're ready to make a drawer box. What I do for this is I then take my drawer slides and I put one against that style. Then I put the second slide against that one. And then I measure to here. So kind of the natural thing is measure the opening, subtract an inch, which is basically what we're trying to do. But this, again, just like conceptually with how I do my woodworking, using gauge blocks, transferring measurements, if I do this, it's one less mental error I can make. When I physically measure the thickness of 2 slides in the opening, what's the difference? This dimension minus a 16 is my drawer box. So it just makes it a little easier than doing. All right, so far, rabbit questions?
Well, one question, but it's, what makes the determination between using the rabbit joint and the other joints? Is it just simply cost and time? Of what
Well,
you're trying to
it's a
do?
great question. This is crazy easy. I'm not a big fan of making, I'll use a rabbit joint on the back of a door box, like when I dovetail the front. Because the back of a drawer gets no stress. It's the front of the drawer that carries, that you're pulling on all the time. So rabbits are really easy to make, but there's no mechanical gravity. So the next two that we're going to do, in addition to having glue in them, they're all going to have glue in them. And given a good joint, today's glues are stronger than the wood you're putting together, but there's no mechanical hook. So the next two we're going to do provide a mechanical hook. So I'm not keen on rabbiting all four corners of a drawer because I don't like the lack of strength it provides for the drawer front. But I would use a rabbit on the back, like I said. If I had dovetails on the front, I'd maybe rabbit the back. Anything else? Rabbit hunting? All right, I'm going to undo what I did, if you want to unplug me. And then we'll do lock rabbit next. So any great time if you've got just general questions of any kind, if you want to throw them out there. I'd be happy to baffle you with.
George, I didn't quite get what you were saying about the screw placement on the door slide.
Do you guys have a set of slides in here by any chance? A set of full extension slides of any kind? I mean, even if they're on a drawer, we could look at it. Yeah, it'll be easier if we can see a slide.
While we're waiting for that, we've got our digital tools guru is in the audience, and he is anxious to hear your comments on
No, I don't think those have them.
the use of CNC in your shop.
Yeah, these don't. These epoxy mounts won't have them. It's the full extension ball bearing, like 100-pound slides is what I usually buy.
He went to look for it.
Okay. So use of CNC, like in what? How? What? Or what's?
So you went from one context in your background to now having 5 CNC. What is it in your thought process that you want to use CNC as such a potent tool in your arsenal?
They're cool. Chicks dig them.
All right.
No, I'm a great poster child for CNC, I think, because I got my first one. A friend of mine worked for Shopify, and he said, "I think you would like this." And I was like, So he loaned me an 18 by 24 shop pod, which then once it was in my shop, if I'm going to use it, I got to figure out how to use it. VCarve is the software that's real ubiquitous to a lot of these CNC machines. Okay. So honestly, it sat there for the longest time. I was helping my daughter at the time make an electric guitar, and I was very torn between when we cut this African black limba that we paid like $100 for a piece about this big. It'd be so cool to CNC that Firebird shape instead of bandsaw, but I wasn't brave enough to do it. So in the end, I can't remember what project drove me to it, but I just started messing with it. At that point in my life, I use a computer all the time. You can listen to it. I'm not sure these have either. I'll look. I use a computer all the time, word processing, video editing, photo editing, but I had never drawn anything on a computer. I'm fluent in SketchUp today. I was not when I got the Shopify. So I had to learn to use VCarve. I had to figure out, well, how is this going to incorporate into what I want to do? And so it was a thing where for me, the more I used it, my brain just started to spin with, well, I could do this. And the more I understood it, the more I saw the possibilities that it offered. When I was a kid, I was raised by basically a substitute father who was an amazing carver and tried to teach me a number of times how to carve. It's not in these fingers, it's just not. However, I can grab 3D clip art and put it into a board. And I realize I'm not carving this. I get it. I'm CNC cutting this thing. But it lets me put an eagle head into a piece of work that I can't possibly do with my hands. It allows me to, in my shop where I'm trying to do woodworking to make a living, that's an employee that shows up sober every day and can always read a tape measure. Well, I mean, it is what it is. You know, it's hard to get good help. It's a machine that can be running and producing stuff while I'm doing 16,000 other things. So the creative capability of it, I mean, now my daughter works for me. She's 21. What she likes about it is, like, we're kind of over the it'll cut wood part. We've cut brass, builder's foam, polycarbonate, used a diamond drag on granite and glass. We're basically just trying to push the limits and see what else we can do with the machine from a creativity perspective. That's the thing she's really intrigued by, is not just, we mass produce parts for 4 different accounts. So that's how we're monetizing the CNCs that way. But from a creativity perspective, she's looking at, she made herself a ring. She made a brass ring for her finger by cutting it on the CNC. So it's that kind of, it's the creative aspect, and it's letting me do woodworking that I can't otherwise do, like the carving. That adds a really neat thing to, you know, I can turn a bowl on a lathe, it's going to come out round because it's a lathe. I can't turn an oval bowl, but I can CNC an oval bowl. So that kind of stuff.
George, after a testimonial like that, I just want to mention, there's one slot left in the upcoming CNC class. Thank you very much.
Do you substitute, do you replace your techniques on the jointer now with the CNC machine? In other words, do you do all your cabinet drawers and stuff on the CNC machine?
Because that's my biggest bet is 2x4. So I did a big cabinet job last summer, and I did all the case sides I produced on the CNC because it only just had the capacity to do it. 23¼ inch lowers. So I could put on a 24 by whatever it was, 40-inch piece of melamine, and it would cut the outside shape, and it would punch all of the adjustable shelf holes. So to me, that was a great use of the machine. And I was, whatever I was doing, I was cutting face frame parts, and the CNC machine was making all my case sides. But stuff like drawer boxes, I'm still doing those on a table saw and a router table or whatever. It's more the case of, I mean, my biggest thing that we do on the CNC machines is we make little free libraries for the Little Free Library. So the Little Free Library is a nonprofit. Part of how they fund themselves is they sell little free libraries. So we produce those in our shop, which we wholesale to the nonprofit, which they in turn sell online. So it's a perfect case of, it's all dado and rabbet joint and 3/4 inch exterior plywood, and every part, it's the Eli Whitney approach to making stuff. Every part comes off exactly the same. And then Ginny assembles, and that's all her account. Then Ginny puts them together, delivers them, and off we go. So they're basically little cabinets whose scale fits on the machines that I have, so it works out great. But it's probably my bigger thing in my woodworking, personal woodworking, is augmenting stuff that I do. So for my kid who just graduated from Marine boot camp, for like $5 you can buy a 12x12 granite tile at Home Depot. So with a diamond in the CNC, I engrave the Marine emblem onto that granite tile. So it's that kind of, how would I do that? If I didn't have a CNC, I couldn't possibly do that. Like I said, cutting brass. I'm in the midst of a table for my daughter. It's a cookie. It's a log cookie with a big crack in it. So I'm going to bow tie, I'm going to bow tie over the crack, but with a brass bow tie. So I cut that brass bow tie on the CNC, and it's a walnut slab. So the brass in the walnut is going to look really, really cool. But I'm still going to hand cut, you know, the negative profile that's got to go into the cookie. I'm going to do that with a router. All right. Yep.
First line.
Oh, yes. Good thing
talk about your hearing protection thing?
What?
Hearing, yeah.
These are like the coolest thing since electricity too. So these are Isotunes Pro. Isotunes is the brand, Pro is the model. They have a couple different models. Net for what we're doing here, 27 decibels of hearing production, 27 decibels of reduction. So as a general rule, stuff in your shop runs about 105 decibels. We need to get it down to 85 to be safe, hearingly. So we're covered there. The Gee Whiz part is they Bluetooth connect to my phone or whatever you want to Bluetooth connect them to. So I have these in my ears from like 6 in the morning until 8 o'clock at night every day. And I'm listening to Spotify or Pandora while I'm working. If my phone rings, I hear it through this, and I can answer on this. If I am on a call, this is, I think, one of the coolest aspects. If I'm on a call and I want to keep working, which I typically do, they have a noise canceling feature. So I can be on the phone running a shop vac and cleaning while I'm wasting my time on a conference call. And it'll cancel the shop vac from the background, and they can hear me talking, but they can't hear the vacuum. And just in testing it, you can run, so I'm not saying I would do this, but I just did this to test it. I can run a router, and they will hear me talk, but not hear the router. So again, don't do this, but I'm just telling you that the efficiency of this noise cancellation thing. Shop vac, router, miter saw, but it needs to be a continuous sound. If it's something that's cycling on and off, it's going to lose it. But if you, what you do is, you don't talk, and you turn on the vacuum, and give it a second, and this hears the vacuum, and then you start talking, and the vacuum goes away. So it's just the pros are like, they're either 80 or 100 bucks, I can't remember. They're on Amazon. And then the less expensive ones are like 60 bucks, but the battery life isn't as long. I think they call the battery life on this 10 hours. It's way longer than that because I don't always remember to recharge them. They say the range is 30 feet. My shop is 3,600 square feet, and I'm good at just setting my phone in a spot and walking all over the shop, and I've never run out of range, so it's way more than 30 feet. So yeah, it's a great product. I really like it a lot.
That's Isotunes Pro.
Isotunes Pro is this one. Ginny wears the ones they more recently came out with. I can Google it and tell you. And she likes those. My only complaint with these is, like, when I'm not using them, I got to remember to do this. Otherwise, they kind of do this, and then maybe they fall. The ones Ginny wears, there's magnets in the earpieces, and she magnets them together, which then, interestingly enough, if you're on Pandora, and you take them out and magnet them, it stops Pandora. And when you unmagnet them, it plays again. So it's very clever stuff, very clever technology. All right, next thing we're going to do is lock rabbit joint, and we'll do this just so that you know, in case like you need to use the bathroom or something. We'll do this one, and then we'll take a little break, and you can stretch your legs, and then we'll come back. The critical thing with this is the slot cutter you use has to be half as big as the material that you're working with in thickness. So 1/2 inch drawer sides, 1/4 inch slot, 3/4 inch drawer sides, 3/8 inch slot. This is the way I make drawers probably 98% of the time. Once you see this setup, it's crazy fast. One bit, one setup does everything. The joint and the groove for the drawer bottom. So once we're set up, it's crazy, crazy fast. The other thing that's nice is with this, you're buying a 1/4 inch slot cutter, which you can use for a lot of different things. The drawer lock bit that we'll do next, it's a great joint, but that's a dedicated bit. All that thing does is make drawers. This makes drawers plus stuff. Bigger diameter cutter, lower RPM. So my rule for that is always change your RPM before the bit goes in, because it's too easy to get distracted. I put this in, and then I'm going to change the RPM, and then I get a call on my isotunes, and I talk to my kid, and then I come back, and I forget that I didn't change the RPM, and then things go bad. So just get in the habit of reduce the RPM first, then put the cutter. We don't need a lot of depth of cut on this. And the wings on this are bigger than what we need, but that's not, it doesn't hurt us. I'm just pointing out that if you get a slot cutter of a smaller diameter, you're still going to be okay to make drawers with.
So what RPM do you use for the 1/4 inch slot cut?
I went down a click, so that should put us at about 18,000 ripples.
Okay.
Then yeah. But thanks for checking. Thanks for asking. Now, the other thing that I think is neat about this setup is the setup is pretty simple. 1/4 inch cutter. Well, let me do this. I'll show you what this joint's going to look like when we're done. Drawer side. Drawer front and back. So this is the lock rabbit part of this. We're rabbiting the front and the back. We're dadoing the sides. So when we do this, because we're a 1/4 inch slot cutter in 1/2 inch material, everything is about your 1/4 inch bar stock. The distance from the table to the bottom of the bit is going to be a 1/4 inch. I'm going to raise the cutter until that just sneaks under there, and don't sweat it too much because a test cut is going to tell us if you did that right. But right there, I can just slip the bar stock under that carbide. Then bring the fence into play. Get the hole in the fence just the right size. Riddle me this, Batman. When I set this fence for what we're about to do, how critical is it that that fence is parallel to the miter gauge slot in the table?
0.
Right, not at all. So router table is a whole different thing than a table saw. This fence can be kittywampus and you're still fine because the rotation is horizontal. On your table saw where the rotation is vertical, the fence has to be parallel to that blade. So that the exception to this is what? If I'm using something, it does have to be parallel. If I'm using the miter gauge, then I have to take the time to make these parallel. I've got the slot in the table. I don't think I've ever used it. So you can be crooked and you're still going to be fine. So back to this. It's all about 1/4 inch. We're a 1/4 inch above. And then now I'm going to lock this end. Span the hole in the fence with my bar stock. And again, I'm looking for top dead center, the point where that wing is at what looks like its maximum circumference away from the fence. Span with the bar stock and make those even or so. As long as they're all the same, you're going to be fine. So this is not, here I'm not doing a fingernail catch. Here I'm shooting for carbide even with bar stock.
Bar stock is resting on the wood, not the roller.
Correct. Yeah. It's not about the bearing here. Yep. Yeah. I'm bridging the fence. So what I'm shooting for is that carbide is now 1/4 inch past that fence.
And that's not a problem to use a metal bar stop on touching the carbide?
Oh, as long as they're just kissing, it's fine. But it's a great thing to think about, like at the table saw, when you take a blade off the saw, you should never set it on the cast iron top. You should never let a blade sit against a blade. A stack of potato is a different deal. But carbide is strong but brittle material. And just that incidental contact between teeth and cast iron can take a tooth off. But here, where I'm just gently putting that on there, you're going to be fine. For testing, we got to do two things. When you make this drawer, this piece, your drawer front and back, get fed horizontally on the router table, and your drawer sides get fed vertically on the router table. To know if this is right or not, we have to do both cuts. All right, set up questions, otherwise I'm going to make noise and chips.
You want to use the little small testers in the test pieces?
Sure. Yeah. I'm forgetting that they're here. This. All right, ready? I'll take a little electricity, please. So I taught I did Peace Corps, and when I taught in Africa, I was at a school with no electricity. So when I got there, the previous teacher had left are there hand tool people in the room? Because I'm about to prove to you what an idiot I am. So the previous teacher had left an inventory of all the tools. So I'm reading this list, and there were 2 routers. We don't even have electricity. Why would there be routers? And I'm looking through all of this stuff, and I can't find a Bosch 1617 to save my life. So it was about 6 months into my educating myself about hand tools before I realized there's a thing called a router plane, which you use to clean out tables. So, all this time I'm like, I can't find the routers. What are those 2 funky looking tools? I don't know what those are, but I can't find the routers. Okay, 1 horizontal, 1 vertical. Couple stumbles there, we'll talk about that. What do you think would be a good way to know if our fit is any good or not? Yeah, put the pieces together. Here's what we're looking for. When we do this, and this is, so joints in general, my test is, can I put them together with hand pressure? And when I lift one, does the other one want to stay stuck to it? Mortise and tenon, dado, same thing. So here, the fit of this joint is this, and you're a very good group because this never happens on the first try. The fit of this joint is great. But we're in the world again of one of 3 things can happen. We get a good fit, good job, or it's too loose, or it's too tight. So we got to think about this. Can you change the size of that slot? If the joint doesn't fit, can we change the size of that dado?
No.
No.
Okay. You can, but would be changing setup.
Okay, so let's use the word no. But you're right. We could if we're avoiding the monkeying around stuff. So we're gonna. The size we get is dictated by the size of cutter you have chosen to use. 1/4 inch cutter makes a 1/4 inch groove. can we change the size of the resulting tongue?
Yes.
Okay, so put on your thinking caps. I cut the joint. It's too tight. They won't go together. Raise the bit or lower the bit. Wow, you're very good. Very fast. Yes. Okay. If we lower the cutter, this piece got fed just like that. If we lower the bit, the resulting tongue is made smaller. If we raise the bit, the resulting tongue is made bigger. The only effect it has on this piece is the relative position of the groove to the end. But this is where, like, the geometry of this thing all plays in. 1/2-inch material, 1/4-inch cutter, so that when we have this right, these faces end up even, or in the case of Baltic birch, they're going to be off, where Baltic birch is 0.423. But it's going to be fine if we trim that later. But this is why you can't do a 3/8 bit in 1/4-inch material, because we won't get this geometry to work out. I stuck my hand in it right at the top.
Because Baltic isn't perfect 1/2 inch, you're just always gonna have a little bit excess.
Yeah, so you'll see when this comes around, there's a little, and I would just glue that together, flush trim it after. And this is actually, this Baltic might be, oh, I guess I can show you. So this is 4.5 right now, and you'll see what we're getting from that.
So when you do the flush trim, you're doing that on the router table?
Typically, I mean, if it's a huge drawer,
Right.
then I'll take a flush trim router to it. But on small boxes, yeah, I'll do that here. Part of it, I use a router table whenever I can because dust collection is good. Where with a handheld router, you end up with it all over the place. Dust.
So this joint strong enough for heavy drawers?
Yeah, so I've got a gazillion shop drawers made just like this.
Like 100-pound contents or something, you can handle it.
Yeah. Well, and it's, so when we do the bottom, I'll qualify that a little bit. But as far as the corner joint goes, so what we buy here is we've increased the surface area over what we had with the rabbit. And now we have a mechanical grab between those two. So even if we didn't glue them, which would be kind of weird, but even if we didn't glue them, if you pull the front that way, you can't get it to come off of the side because they're hooked together. So it's kind of like a dovetail, you know. The whole deal with the dovetail is the tails are in the side, the pins and sockets are in the front. So you can't separate them in that direction. Same thing with this one.
You know, one other advantage that I see is that this will get you a square box all by its own geometry, pretty much.
Yeah, assembly is very easy on these. All right, now on these pieces that we're working with today, the grain is going like over the height of the drawer. Normally, the way I would do a drawer box is the grain would be running the length of the fronts, the lengths of the sides. So I'm going to take one of these scrap pieces and do a drawer side cut just to show you something. This didn't come out too bad. Too bad. What I'm looking at is the chipping there. So one of the downsides to Baltic birch is it is a very chippy material. So typically, when we do a cross grain cut with this or with the drawer lock bit, you really get a lot of chipping. It can be to a point where, like, there ain't no way I'm using that piece in my drawer. What you need to do is get your setup right. You need to do test cuts and just live with the chipping for the test cuts. When you get to a point where you know the height of the bit is correct, then we zero clearance the in-feed side. So what that means is, I loosen the in-feed fence, run the router, is that on the first go-round in Baltic birch, the chipping is like the Grand Canyon on the inside of your door. This simple step will completely eliminate that chipping. You only do it on the in-feed side. You don't need to do it on the out-feed side. Now, there's another really cool thing about what I just did. I just got something for nothing, which doesn't happen often. I got a gauge for the next time I make this. Because there's a distinct height for this cutter that makes it work and makes the joint fit. Now there's a hole in my fence that tells me what that height is. And with most of these router table fences, you have 8 opportunities to do this for 8 different pits. Because I can take this off, well no, so on this one it's not 8, it's 4. So I can take this off and rotate the whole fence, which we're going to do later for the drawer lock, and do the same thing to this corner for a different bit. Then I can take this one off and put this one on, and I have 2 corners there I can use. The reason I said 8 is like on a Jessam router table, you can rotate them and you can flip them. So you can use all 8 corners of your in-feed and out-feed.
Is the pre-finished chip less than?
I don't know. I haven't worked with this stuff much, so I'm very impressed with how little that one I just cut chipped. Pretty amazing. So when I said earlier there were some stumbles along the way, one of the things that just happened is we narrowed the opening. So that makes it easier to do your feed because the part's not going to collapse into the opening. And then the other thing is, I don't know if there's an adjustment on your insert, but the insert is just a skosh below the table. So I'm assuming there's jack screws under there that will let you bring that up. It needs to come up just a bazillionth of an inch.
Can you make another cut to demonstrate?
Nope. Yeah. Because now we got everything right. So now we got to make, like, what would a drawer box look like? Okay. So let's test questions. I'm about to cut 2 parts. My drawer fronts have now been cut to a very specific length so that they fit between my slides. My sides have been cut to a specific length to work with my slides, okay? So which part gets fed horizontally, the fronts and backs or the sides? Okay, fronts and backs. Fronts and backs get a ton, sides get a groove. So here's another just general woodworking thing. You're making a kitchen full of drawers, a shop full of drawers, whatever. You've got 4 of these per drawer and you're making 20 drawers. I think that's 80 pieces. What you should do is stand at your bench, listening to Pandora, Johnny Cash, not running tools, and with a pencil, front, side. What I don't want you doing is standing here, router running, looking at parts. I'm pretty sure that's a front. Because 1, you're taking your attention away from this tool that can cut your fingers off, and 2, it's really easy to screw up. It's really easy to make mental errors under that circumstance. Same thing when you're making cabinet sides. You have an inside and an outside. You have a top and a bottom. So just a couple minutes at the bench labeling stuff creates a roadmap that helps guarantee you're going to machine them correctly and you're going to be safer doing it. So before you get here, label your parts, and then they could also have an inside-outside. I mean, Baltic is pretty interchangeable. But if you have a face, well, if you've got like footballs, and on a drawer box, I'd want the footballs to the outside, because you never really see the outside of the drawer, you only see the inside of the drawer. So then I would call that out as inside-outside. when I do this cut, I'm about to cut the face. Is the inside of the drawer box down or up? Somebody's going to get voted off the island. Insides are down. On the fronts and backs, the insides are down. On the sides, insides are against the fence. All right, so
Did you say that again?
on fronts and backs, the inside of the drawer box is down on the table. On sides, the inside of the drawer box is against the fence. So first step, we're going to just rinse and repeat. First cuts here, I'm going to do exactly what I already did. One horizontal, one vertical. Okay, but we don't have a drawer bottom yet. So the next step is, my promise with this was one bit, one setup, the entire drawer. The next thing we do is make the groove for the drawer bottom. Your drawer sides will go against the fence with the groove, the dado you just cut is against the fence. Your drawer front and back go against the fence with the rabbet you just cut is away from the fence. With this approach, this is the biggest spot for mental error, is machining the wrong face for the groove. Because it's like, it's different between the two. On the drawer sides, the machined face, on the drawer side, it's the machined face that gets the groove. On the front and back, it's the non-machined face that gets the groove.
That's for the bottom.
Correct. Then, so the result of that is we get the interlocking joint and you get the groove for the drawer bottom. So now this is in the world of, I want to put hand planes in this drawer. Maybe you want to only do the corner joint here because you're going to do a half-inch drawer bottom so that the bottom is more substantial. So I'm not worried about the corner joint as far as the strength of the drawer goes, but if you're going to fill the drawer with lead, you might want something more substantial than a 1/4 inch thick bottom. So maybe you want to do something different for the groove. But kitchen drawers, most of my shop drawers, 1/4 inch plywood for the bottom. 1/4 inch ball is what I use. Nope, so what I do when I make drawers is the back ends up being, so this is a front. This is a front. On the back of the drawer, I cut it to this width. There's no groove on the back. And then I put the whole drawer together. I sand the inside faces. Don't worry about the outside yet. Sand the inside faces, assemble the drawer. Sand the outside faces, spray the drawer, seal it. Finish the bottom, pre-finish the bottom. Then slip the bottom in and fasten it to the top of the back, or the bottom of the back. And typically with staples, crown staples. So it's just easier. Finishing a drawer is really hard if finishing the inside of the drawer is really hard if the bottom is already in. So lazy woodworker that I am, it's easier to finish the drawer box with the bottom loose and finish the bottom with the bottom loose. And then two, just in general in drawer construction, if something's going to fail, it's probably the bottom, especially a shop drawer. So because it's stapled here, if I needed to, I could take the staples out, take the bottom out, put in a new one, and I don't have to destroy the drawer to get it out. If you're going to make really narrow drawers, so maybe you're making like a little, like a mechanic's tool chest that's going to sit on your bench because you're going to put your little block planes in there or something. So where I'm going is, if these parts are going to be much narrower than we have right now, the way to do that is don't cut them to their final width yet. So if I want a 3-inch drawer, I'm going to do this to 6.5-inch wide pieces, but half as many as I need. So when I do this to a 6.5-inch wide piece, I just made a front and a back. But it's much easier to handle on the router table than those skinny pieces. Because of the way we have to go against the fence, those narrow pieces are going to walk. So anything that's narrow like that, just leave the part wide. And then you're getting 2 for 1 when you do your cut. All right, lock rabbit questions. So in the world of completely useless trivia, is this a dado or a groove?
Yes.
This could be, you could be on a game show, and this is the question that, Alex, I'll take stupid woodworking questions for 1,000.
Dado is cross-grain. Dado is cross-grain.
Dados go across the grain, grooves go with the grain. So it's a stupid, subtle little thing, but just in case, now you know. So this is actually a dado, because the grain on these is going. All right, anything else on this joint? Otherwise we'll take a little break, and then we'll come back and do drawer lock. So I'm the worst guy in the world to ask finishing questions, because I know primarily how to spray lacquer. That's mostly what I do. So my finishing protocol is, like on a drawer box, I sand only the inside faces pre-assembly, and I'll sand those to 220, 221, whatever it takes. Movie reference. I'll sand those to 220, glue the drawer together. Glue squeeze out, the way I always deal with that is I let it squeeze out and I leave it alone. And those glue beads will get rubbery in about 15 minutes or so. And then I've got glue chisels, not my good chisels, I've got glue chisels. Then I slice those beads out when they're rubbery, sand the outside, and then in the spray, in the finishing world, my base coat is always Zinsser seal coat. De-wax shellac is what it really is. So I do a base coat of de-wax shellac, and my top coat is aqua coat, is a water-based lacquer. So I spray the whole drawer inside and out, and the drawer bottom, top and bottom, with the seal coat and then aqua coat, water-based lacquer.
The spray never fill the groove such that it's hard for the bottom to slide in?
Nah, because it's not, both of those, both the shellac and the water-based lacquer are pretty thin products. If you were, I don't know, brushing on a polyurethane, you might have that issue you'd have to kind of watch for, just not let it, if it goes in there, clean it out right away. But it's not a thing with the shellac or the water-based.
So you don't use pre-finished because of expense, or?
Yeah, it's crazy expensive by me, and two, like, I don't know, I guess if I could get away with it, maybe I would, but I feel like I'm going to end up sanding the outside of the drawer to some extent, no matter what. I don't know. I'd have to think about it. I guess the stuff I could get from my supplier, so like I said, I'm paying $19 a sheet now, and I priced it once. It was crazy expensive for the same product pre-finished. So for me, it's just not worth it.
Your glue joint goes
Yeah, I mean, you got a little buildup there, and you're gonna trim the outside when you're done, so you're gonna have to put some, well, I don't know, I would take that back, because on this drawer box, if I was using this pre-finished stuff, and I didn't break it. If I were using this pre-finished stuff, and I did a flush trim there, and it's gonna get a finished front, then that doesn't bother me that that's raw, because it's gonna get covered with a finished front anyway. And the back I wouldn't mess with, because it's the back of the drawer. So you'd have to do the tops, you'd have to shoot something on the tops to get those done, but yeah, it's not cost effective where I am to buy the pre-finished stuff.
Myself, what I do is I use it on the pre-finish, and what I've got is one of those applicators you use, like the PVC glue, you can buy them like that. And I just dip it in water-based poly and run that little cotton guy over the top. Gives me a perfect finish right off the bat.
Yeah.
And that seals it up, it looks like the whole, looks perfect.
I mean, the nice thing with the pre-finished stuff is if you get squeeze out, you can deal with it right away, because you can take a wet rag and wipe squeeze out off a pre-finished surface. You don't want to do that on raw wood. But it would save a lot of monkey around. And finishing inside corners stinks. Like spraying it isn't as bad as wiping it, but it's hard to get a good quality finish when you have the inside corners. So if it works for you, do it.
George, do you pre-finish your panels before you cut them up? So if you buy your 5x5s, do you pre-finish those?
Yeah, I was just trying to think like, I've done it and I can't think of why I did it, but that's how rarely I do it. So typically no. The old Navy stores were interesting. They were, I don't know that they're made this way anymore. But it was, they spec'd wheat-based particle board. It all came from North Dakota. So it wasn't a wood product, it was wheat. It smelled like wheat, it smelled like Cheerios when you put it. Non-formaldehyde glue, and it came pre-finished. So that the old Navy stores had this uber industrial look. The countertops were galvanized metal. So we had that formed and broke by an outside supplier. And then this just lacquered wheat-based particle board is what all the store components were. It was cool, kind of, but we consumed miles of it, miles and miles and miles of it.
Just want to make sure I got the sequence right. So you sand the inside of the drawers, and then you spray them before you...
No. Sand them, glue them.
Sand them, glue them, and then spray outside and outside.
Sand them, glue them, sand the outside,
right.
Spray.
Okay.
And if I'm pretty confident in my dimensions, I'm trying to think. So I just did a dresser. We just shot a video on making a dresser. So I'll make all those components, finish them, and then go back and put the hardware on. So the alternative route is put the hardware on while everything is raw, and what does that buy you? The opportunity to maybe do what if you need to? A little tweaking, a little sanding, so if you're not 100% sure that your slides are going to work okay and you got all your dimensions right, then it's a good idea to put the hardware on, make sure everything plays nice with each other in case you got to do a tweak, then go back and do your finishing. But if I'm confident in how I got through the process, then I'll build everything, shoot everything, then go back and put the hardware on. So I'm not putting it on, taking it off, finishing, putting it back on. And same with drawer hardware, like Euro hinges on a door. Generally at this point, I just make the whole door, finish it, then go back and punch the holes with the door. Okay, drawer lock. This little guy is, I caught Lou at just the right moment there. Water break.
Thanks, George.
Do what I can.
I'll get even.
This is a drawer lock bit. So like I said earlier, this is purpose specific. All you can do with this is cut drawer joints. However, once we get this right, it's another crazy fast, really strong way to make drawers. Comparatively, we can sort of talk about drawer locks and lock miters. Lock miter bits can really make smoke come out of your ears. Lock miter bits are difficult to set up. That would be a good one for us to do a live stream on. because I've got tricks for that. Lock miter bits are way fussier to set up than this drawer lock cutter is. So what we're going to get from this is increased surface area in the joint, which is then good for gluing, and a mechanical grip between the front and the side that prevents you from being able to pull the front or back straight off the drawer. Way faster to make than a dovetail. And I mention that because you get the same thing from a dovetail, that mechanical interlock. Drawer lock cutters are dimensionally specific. So a specific bit will work for material from X to X. This is a white side bit, like 2464 or something is the part number. This will work great with our 1/2 inch stock. If we were going to 3/4 inch stock, then they just stretch the profile out so that it works with thicker stuff. We're unplugged. Oh, let me do, because this is our last cutter, I'm going to tighten this, because I wanted to mention this when we take bits out. When you take a bit out of a router today, I just tighten that down. So now I'm going to loosen it. And I crack the nut loose, but the bit won't come out. So remember what happens with the collet is we squeeze and we draw it down. And inside here, the recess in the shaft is tapered. And then the outside of the collet is tapered. So when I do this, it pulls it down into that taper. That's what helps holds it in. So when I was a kid and had to do woodworking, then at this step, you would tap the router bit to get it to pop loose. So what has changed in collets is that right here on this, the Porter cable approach is, there's a snap ring right here. So it's a 2-stage deal. So when you get to this point, this is loose and this won't come out because you haven't gone far enough yet. From here, we need to back this out. So it's still that nut is still unscrewing. Right now it just kissed the bottom of the snap ring. And if I go a little more, when I unscrew that, when it hit that snap ring and kept going, it pulled, there's two parts. There's the collet nut and the collet. It just pulled the collet free of the internal taper in the shaft, and then the router bit will come out. Yeah, I'm jokingly saying the tapping on the router bit thing. I mean, it was the only thing you could do, because back in the day, you could take the nut completely off and the collet could be still locked up inside the shaft. So the only way to get those loose was to tap on them. But it's pretty much everybody today has I think everybody today does have a self-releasing collet. And if you've got an older router, if you've got a Porter cable 690 with an old collet, this collet fits it. You can buy it for 25 bucks. So you can upgrade your collet without having to buy any router. All right, height of bit. I am going to, we're gonna lean on Lou for this, but I'm gonna do a drawing too, because this is funky. That router bit that's sort of our drawer lock cutter. Net, we're basically going to produce a tongue and groove joint here. So this part of the cutter is going to make a groove because it's sticking out off the bit. So when we run our material past it, it's going to make a groove or dig. So when I set the height of this cutter in the table, knowing what you know now, knowing what you know from the work we just did with the slot cutter, you know how to get this height right So when I adjust this height from the top of the table, look at it, we can use a different color. The top of the table is here. What's the distance from the top of the table to the bottom of that?
Quarter inch.
We don't know a number. We don't know a number.
The thickness of the piece?
Thickness of the something.
Of the side?
Okay. So we're going to machine our pieces the same way. One piece is going to get fed horizontally, one piece is going to get fed vertically against the fence. So the way to think about this is that this is going to make a groove that will always be the same size, right? Because it's a slot cutter, basically. It's a groove cutter. When I eyeball this in the table, I'm going to try to set this so that the distance from here to here is equal to the width of that slot cutter. Because this gap down here is going to give me what? It's going to give me a tongue, which has to fit into that groove. So we can't put the bar stock on here because we don't, this is some number for white side, it's some dimension. I don't know what that dimension is. So what I usually do is just get down here and do this until the distance from this corner to this surface looks about the same as this. And don't sweat it much, because a test cut's going to tell us everything.
Why don't you use your gauge like you did before?
Because this isn't a quarter inch.
Oh,
It's 80 bazillion 30 seconds, or it's some weird, I don't know what it is. But the good news is, you're going to pull your hair out the very first time you do this, and then you're going to never do that again. We have to suffer once. And once we suffer through it once, it gets way more easier.
George, is there carbide at both tiers, both levels?
Is it what?
Is there cutting edge at both levels on this bit?
Yeah, so this is a carbide flute, and this is carbide, this is all one piece of carbide, shaped just like that. And there's actually a little bit of an angle there, which will come into play when we make the cut. Yeah, had I been thinking, I would have shown you the bit when it was not in.
There we go, okay.
George, could you draw on the board what the joint will look like put together?
Ooh, this is a way harder one.
you only have to do it once.
Yeah, let me think. Side. And don't hold me to this. Front and back. So, I got this part. The wedge is here. And then this is straight. So, it's very similar to what we just did. This is our front and back. We're putting a tongue on the end of the front that has to fit into the groove that we're going to create in the face of the side. The size of this groove is dictated every time, no matter what, by the size of the carbide flute on that side. What we can change by the height of the cutter is the resulting tongue. So conceptually, it's the same as what we did with the slot cutter. We just don't get the benefit of being able to use the...
advantage of this joint over the other one we just did is the additional groove surface.
Like, I would interchange them. You know, I think we're doing this because people want to know how to use a door lock bit. If you said to me, which one of these cutters should I buy the slot cutter, because net, it's an easier setup, and you can use it for other stuff. But if you want to make a drawer lock joint with a drawer lock bit in drawers, then we need to know how to do this. But from a practicality perspective, there's not, mechanically it's very, very similar to what we gain by using the slot cutter. And what we can't do with this one is cut the groove for the drawer bottom. So if that setup we just did with the slot cutter, that's my go-to drawer making setup.
So ooh, when the customer looks at it, goes, oh, that's, oh man.
It's like the only reason to do a lock miter. If you do a lock miter and you can't see it when the project is done, you're crazy. Because it takes like 4 days to set it up. And I'm gonna use contrasting wood so everybody can see that I did the lock miter. All right, let me look at this again. Yeah. Okay, so that's probably, I don't know, it's reasonably close. Test cuts will tell us. I'm gonna switch my fence, or your fence, because I don't want that 1/4 inch slot in it now. And then for fence position, what we're gonna do, we are gonna use the gauge bar here. What I'm gonna do is set the fence so that the bit is sticking out half the thickness of our material. This is just a starting point. It's not gonna be right. But we need some place to put the fence. So I'm gonna set this bar stock, 1/2 inch stock. So I'm setting this so that the bit is projecting 1/2 inch, or I'm sorry, 1/4 inch past the face of the fence. Then, for our test cuts, one piece going to get fed horizontally, one piece going to get fed vertically, and the result will tell us what we do, or what we need to do. You go ahead. The fence position is a big deal to stay safe with this. Because if we put it too far back, we could set this so that bit's going to cut all the way through that vertical piece. That'd be really bad. So it's really critical you get that step right. And I'm not worried about it being perfect, but we got to make sure the tip of that cutter isn't out too far, or you're going to destroy your material. All right, we're about ready to do a test cut, unless you have a question.
Same speed.
Now I went back up to full speed, full bore. So, this was my vertical feed. This was my horizontal feed. And that's what the joint should look like, but it's too loose, Latrec. It's too loosey-goosey. So vertical, horizontal. We get the tongue on this piece, which we can change, right? By raising and lowering our bit, we can change the dimension of that tongue. What we can't change is the groove that we're producing there. That's dictated by the slot cutter. The groove that we get there is dictated by the slot cutter. So we have two things that we're looking for. One is, do they fit? Which they don't, they're too loose. Test question coming in a second. The other is, do they meet okay this way? Meet okay being, this is my drawer front. Does that drawer front come out slightly past the face of the drawer side? So the answer is no. All right, I want to tighten up the joint. What do I need to do? Okay. Okay, move the fence, raise the bit, lower the bit. Got to raise the bit. Because the tongue, right, when we did this cut, this tongue is too small for this groove. So no matter what, the groove is the same size. The groove is always the groove. But we can make the tongue bigger by raising the bit. So when we look at this, I'm going to get the chips off of it. So when you look at this, the gap in that joint right now vertically is how much?
16th or something.
Okay, 16th. This is a direct read, meaning when I look at this, if that gap is a 16th, I raise the bit a 16th. This is where a router lift is nice. Because typically on these lifts, a full rotation of the handle is a 16th of an inch. So I'm going to say here, I'm going to do half of that. I'm going to do a 32nd. I'll pass this around in a second. All right, now this way, that end grain doesn't line up with that face grain. How much is it off? About a 16th. That's a half read. Because when we do this cut, broop, broop, we're doing that to both parts. So the loosey-goosey part, direct read. Raise it the amount you think you have a gap of. Is that confusing enough? Whatever the gap is in the joint, that's how much you raise the bit. The offset in this is half that amount. So I'm going to do a half a turn up. And then what I usually do is, on my router table, I take a pencil and mark the existing fence position. And then loosen the fence, and I'm just going to like eyeball a speck of dirt on here. What I'm trying to do is keep track of where I am right now and the change I'm making. So on this table, it's nice that this insert is silver. I would take a pencil and I would drag it across the face of the fence. I was avoiding it, so if I screw up, I could say, well, it's only because I didn't have a pencil. But thanks for calling me out. All right. I'm going to mark the existing position and then watch that and move the fence back. So I opened it up maybe a 32nd of an inch. I want the same thing here. I want the front to end up past the side so that I can flush trim it later. All right, questions, preguntas? Anything? All right.
So you want 30 seconds each way?
I want, well, it happened to be about the same adjustment in this case in both parts, but that's coincidence. So I raised it a 32nd to tighten the tongue in the groove. I moved the fence a 32nd because I think I need to gain a 16th on the overlap. And then we just do the same thing all over again. You have to cut in both planes to see what you have. Hanging up a little on me on that pass, but we'll figure that out. All right, then we do the same thing again, and I can see the tongue is bigger, so that's good. We do this. Oh, this is really close. So let's do this. This is the first one. I'm going to mark this with a 1 and a 1. This is the one it's too loose and the overlap is not right. On this one, it's really, really, really close. And what I'm looking for is, the thing for you to watch for when this comes around is, right now, there's a little bit, it's not quite closing. And I'm okay with that. This is where I mentioned earlier, there's a wedge shape in the cutter. And we can see that wedge shape translate or telegraph to the cut right there. So what's cool about this right now is that I put glue on here and I clamp this and pull it closed, and those two wedges pull against each other. And the net effect of that is it closes the inside corner on the drawer. So I want, let me look at this again. That part of the joint right now, yeah, I would leave that where it is because a clamp is going to close this. So when I pass this one around, and you look at this, this is 2. That's the fit I'm trying to get. I want it to not quite close, so the clamp will close it. And then that forces those tapers to pull against each other, which helps close the inside corner on the drawer box. Then our other thing is this right. And that one feels pretty good too. So this joint is done when this one comes around.
And that one still should be just a little proud.
Yeah, there's just a fingernail catch right there. All right, now this, when you look at this, it's a little different than the lock rabbit we just did, in that the drawer front projects over the side. On our last one, the fronts and the backs just went into the side. So when I make my drawer fronts and backs, the length of the front is equal to the what? The finished width of your drawer. The fronts and the backs are the same as the finished width of your drawer, because it completely overlays and comes to the outside. Now,
How do you clamp it? Across the front or the back?
yeah, only across the front and the back. You don't need to, so you don't need to pull front to back, because the joint is closing that. So I don't think I said that right. You're going to clamp it from side to side. And same with the lock rabbit. You only have to clamp side to side. Pulling it front to back isn't going to gain anything.
The advantage of the drawers, when you go keep them tiny, one of these joints easier to do than the other. In other words, when you want to glue them together and keep them tiny.
Keep the drawer square. Either way, you're going to clamp it and check it. So I don't think there's a gain there.
Okay.
So you said the front and the back are the exact same as the opening? You don't have any?
No, are the size of the drawer box.
The drawer.
So you have to do your math and figure out, if I'm using slides, then you have to do the slide reduction. If you're not using slides, then you don't. And a cool thing, I learned this from a little Chinese jewelry box. If you're making drawers that just go into an opening, so you're making a little jewelry box, and you're not going to use slides. A cool way to get the drawer to work really nice and be a really tight fit is to make the back of the drawer slightly smaller than the front of the drawer. So when it closes, the whole drawer then, to grossly exaggerate, is built in a taper. So when it closes, it's kind of finding its way, it's wedging into the opening. But when it's all the way closed, the front is the right size and it looks great. But because the back is a little smaller, everything tapers trapezoidally toward the back. And it lets it operate without hanging up, but still maintain tight tolerances between the front and the opening.
So you always use side slides?
Well, I just built a huge workbench. I didn't put slide. It's got 12 drawers in it, and I didn't put slides because I didn't want to spend like 12. I didn't want to spend $250 on drawer slides for it. So they just open and close in the openings. But if I'm doing, like the dresser I just built is full extension slides, and nine times out of 10 I'm using slides. And certainly, piece of furniture, a kitchen cabinet, anything like that, I'm putting slides in it.
Did you say why you choose this one over this, the previous one?
Yeah, there's no real compelling reason except you want to use a drawer lock bit.
Okay.
So at the end of the day, if you were asking me which one should I do, I'd probably say just do the lock rabbit, because then you own a slot cutter you can use for other stuff, and the setup is less fussy. And you still get the mechanical and the glue surface. But this is, some people just want to do a drawer lock.
Could you just address the issue of as you're sliding across, you clearly got hung up in various places and how you respond?
So one of the things we've not done yet is zero clearance or in-feed fence. So when we do that, one of the things we're going to gain is this opening is going to get narrower, and that makes it easier to feed the vertical. Because part of what's happening is it's kind of, the bottom corner is kind of collapsing into the opening as we come by. So typically, because the grain is going this way, when we do this cut, we have that same blowout problem on these pieces that we would on the slot cutter. And the fix for that is to zero clearance this, and then adjust your insert so it's not below the table. And that'll eliminate the hang-up. The really good news with the drawer lock, this is not true of a lock miter, it's only the drawer lock, is that the correct height of that bit is bit specific. On a lock miter, the correct height of the bit is thickness specific. So every time we use different thickness material, you have a different height. So when I have joint number 2 that works, you can keep one of those pieces and use it as a gauge to set the height of this cutter the next time you use it, and the height will be, I'd still do a test cut, but you're going to be really, 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 really close. Because it's all about the size of the groove and the size of the tongue, which is never going to change. What does change on my setup when I change material, or what could change? The fence position. So the fence position is related to the thickness of your stock. But the cutter height is the cutter. And that will always be the same. Now, there's qualifiers to that. So, with the slot cutter and with this bit, I said, we're going to find this setup, and it's going to be a pain in the butt the first time you do it, but then now we've got a slot in the fence, that can be a gauge block. Now we've got these pieces going around, that can be your gauge block, until what happens?
Tear it apart.
Something is going to change this, and then we're starting from scratch.
Thickness of the material.
No. No, both of these are, both the slot cutter and the drawer lock, the height above the table for that bit will always be the same
Until the bit wears out?
Until you get the bit sharpened. Because every time you sharpen, you change dimension of whatever cutter that is. Router bit, table saw blade. It's a very interesting thing with the CNC is that a good sharpening service will send your router bits back with the new diameter of the router bit marked on the router bit. So my 3/8 router, I've got 3/8 router bits for the CNC that are now 302 instead of 375. So when I'm setting up a cut in the software in VCarve, if I want parts to fit together, I have to tell the software that bit is 302 instead of 375. So it compensates. So here, we're all good. I mean, this is going to cut miles of door boxes before it needs to be sharpened. But once it gets sharpened and you measure across those flutes, they're not going to be 0.25 anymore. They're going to be less. And then you would do your setup again. And same with the drawer lock bit. It's thousandths of an inch, but it'll change the relationship between the two cuts. The other thing I was going to say is, or let's do this first. Other drawer lock questions. I can zero clearance this if you want. I'm going to zero clearance this. Or I'm saving the corner on your fence is all.
Send these back.
Okay, so let's go back to this, because I didn't mention this.
If you want to leave the bit, go ahead.
It's your cutter. It's funny when I was doing the woodworking show is heavily included here in San Diego. I mean, and we've all got stories like this about air travel. I would check my clothes, because who cares if my clothes get there? But I would carry on the plane with me dado heads, hand saws, hand chisels. You know, I would have a bag full of woodworking tools that I would bring on the plane and put in the thing, because I got to have my tools when I get to the show. If my underwear's not there, I can work around that. But yeah, today that's not so much a happening thing. On the slot cutter, so on the lock rabbit bit, remember when we started talking about dimensions, what we had to do in order to determine the lengths of our fronts and backs. So the same thing is true here. You get your setup right, and then make another one of these, and measure with your fractional calipers how much meat is remaining here. So, because in order to know the length of this piece, which butts into these pieces, we have to know how much wood is left on the outside of this joint to do that calculation, so that we get the drawer box size right. So the first step is to get the setup right. And then, just like we did with the rabbit, take two of those dadoed pieces, pair them together, and measure what's left. That has to be removed from the drawer box dimension to get the fronts and the backs the right size.
What kind of glue do you use?
Sticky. Just regular yellow glue on drawer boxes is great. Regular carpenter's glue, like Type Bond Original, is fine. I'll use Type Bond 3 for pretty much anything that's going to live in a damp environment. I don't use 2 very much. So the difference is Type Bond Original is not waterproof or water resistant at all, but it's less expensive than Type Bond 3. Type Bond 2 is water resistant, Type Bond 3 is waterproof. So if you're doing like an Adirondack chair that's going to live outside, but you're not submerging it in water, Type Bond 2 would be fine. But a cutting board, a planter that's going to be filled with dirt and be moist most of the time, 3 is a better choice. 2 and 3 are both FDA approved, so like in a cutting board, they'd both be fine. But because of the harsh environments for cutting boards, I use 3.
So I have a question about hide glue versus Type Bond Original. So hide glue, a lot of chair makers and so forth use it because you can take it apart.
Reversible.
Is that the same idea as original Type Bond? Can you actually take joints apart?
Well, PVA is way harder to reverse than hide glue.
Yeah.
I mean, you can, but it's not going to come apart as clean.
Yeah.
So the deal with hide glue is a little bit of heat and a little bit of water, and you can dissolve hide glue. And in fact, in a lot of cases, you can just about use the same glue to put it back together. You know, the residual glue on the joint, reheat it and re-wettened, and you can pretty much put the joint back together. So a lot of instrument makers, that's why they use hide glue. So if you ever have to take the soundboard off a guitar, you can remove it, work on it, fix the broken brace that's going zzz every time you play a G chord, and then put the whole thing back together. So for me, I wouldn't use hide glue necessarily on mortise and tenon on the furniture, but if I was putting a piece of veneer on a one-off piece, I might hide glue that, because it's easy to damage the veneer on a tabletop. So then same thing, it gives you that opportunity in the future to remove just the veneer and replace it if you want to. I don't use hide glue very often. Traditional hide glue is dicey, because you heat it to use it, you put it in a pot, melt it, and it cures by cooling. So as you're brushing it on, it's starting to cool. You gotta move pretty quick, or it's gonna get away from you. Type-on makes a hide glue that you can just pour out of a bottle, and you don't have that heat issue. But it's still, it's like gluing with honey, sort of. You know, it's a funky glue to work with.
Slides around a lot or something, or?
Yeah, and it's just, it's real thick. So when you put parts together, it's easy for it to, it's easy for it to get like too much on, and then you put parts together and it squeezes out of the joint, and it'll still cure and you can cut it off. But it's just not, I guess I'm being a jerk. I'm not allowing some future fixer-upper to fix my furniture by reversing my hydrants. I don't know. So if I'm making a chair or whatever, I'm just putting it together with yellow glue.
I use a lot of pre-finish for my drawer material, and I use a roux glue to glue on that one.
Yeah, so roux glue, the big claim to fame there, like melamine is a material that glue won't stick to. Melamine is particle board with a plasticized surface. Roux glue and polyurethane glue will stick to that surface. So same thing here. If we put polyurethane glue between these two faces and did this, they would bond. Yellow glue would not. Because yellow glue relies on the porosity of the surfaces to get a bond. Polyurethane glue doesn't need that. Roux glue doesn't need that. So it's a good alternative on pre-finished stuff. If you wanted to glue unlike materials, so a little piece of solid surface countertop or brass to a piece of wood, polyurethane would work for that. Yellow glue would not.
Isn't there a site, something like this-to-that.com, which allows you to take any two materials and it will tell you
I don't know.
what works best?
I don't know. It'd be cool if there is.
I think it's this to that. I'll check it, but you can find out whatever two materials you want to bond together, and it'll tell you what adhesive to use.
Yeah, that'd be great to know. Yeah, I don't know.
Going back to the final length of the front and back, so I see what you mean about there's going to be a little extra on each end, but I didn't get the caliper part. Are you putting the two sides together?
Yeah.
And putting the caliper in the groove?
Groove to groove.
Okay.
Yeah, so, and I should have cut a second side when I still had that bit in, but I didn't.
Okay.
So this is parts is parts and pieces is pieces. Where's that? Oh, that's a drawer. Yeah, so the two sides, make a second one of these, and then measure from the bottom of this groove to the bottom of this groove, and the meat that's left there is the deduction you need from the drawer box to calculate the fronts and the backs.
Okay, thanks.
What about dovetails? We talked about those, are just too hard, or?
Oh, no.
Damage, or disadvantage?
They look cool. So it depends on what I'm doing. If I'm building a kitchen, I'm not going to dovetail the drawers, especially if I'm building a kitchen with Baltic birch drawer boxes. You can dovetail Baltic birch, but your bit better be really sharp, and it's such a chippy material. So for me, I'll dovetail something. I don't know, if I'm making a little box as a gift kind of a thing. I'll dovetail that. As a drawer box joint, if I'm making a nightstand with a single drawer in it, then maybe I'll make that drawer out of poplar or something instead of Baltic birch, and I'll dovetail that. But in a commodity making a bazillion drawers kind of a way for my shop, I'm going to drawer lock or slot cutter because it's fast and very, very, very strong. In a I want it to be cool way, then I'll dovetail. And it's, the first thing people do when they look at your stuff is they open the drawer and, oh, it's got dovetails. Must be a really good one. Nah, I just bought a really good jig. Here's the thing with all of this stuff is there is probably in everything, but I see it in woodworking, kind of a gizmoization of stuff. So all you got to do is go to a woodworking show and you can see this. And it's a mentality of if I had this thing, if you buy this bit right now, What would it take for me to put you in one of these cutters right now? If you buy this bit, you will make perfect drawers for the rest of your life. Well, it's not. So, I play a little acoustic guitar. If I had a $5,000 Martin, it would be a little easier to play than the marginal guitar I play today, but it's not making me a better guitar player. At the end of the day, you still have to practice all of this stuff. And I think part of our problem as woodworkers is what we think is practice is on Christmas Eve when we're trying to get the gift ready for Christmas Day. We're cutting our block rabbit for the very first time and we're calling it practice. What you really need to do is just get some Baltic birch or get some poplar, or get some commodity wood, and just go to the shop and make the joint that you don't need for anything. But keep the parts and put some notes on there and take the time to do the practice so that when you really need it, you've got it.
Ask Pete about that. Christmas Eve.
So it's, I mean, there's lots of great, the Porter Cable dovetail jig is a wonderful thing. It's they did a really good job making that jig. However, you can use it incorrectly and get lousy dovetails. So it's just, you gotta put the hours in. It's the same with me teaching this stuff. There's all sorts of wood heated in my house because it was too crummy to use for anything when I was done with it. Before I was willing to get in front of people and do this kind of stuff. So it's just, you gotta practice. All right, you've seen my drawers.
Let's call it quits.
All right.
Questions?
Any other questions?
Answers? Smart comments?
Now's the time.
Do you have a card, business card, or anything?
No, but I can write my stuff on here. So there's a couple things I can give you. Please. So this is me. My site is my name.
Do you sell your videos through your site?
I sell them. I don't have a clearinghouse on it. Like, if you know what you want, or if you want to, if you say, like, if you email me and say, here's a topic, you cover this, I can let you know it. In other words, I just don't have I don't have e-commerce for the videos on it. So my site, where that's classes in my shop or wherever I'm going to be next, shows up. My email, which you're welcome to use, or I wouldn't be giving it to you. On Instagram, Vondriska Works. That's actually Instagram and Facebook. I'm way more active on Instagram than I am on Facebook. And then what Pete was talking about, www.goa.com. So to date, I've done about 125 or 130 woodworking DVDs on different topics, and about 1,000 6-minute clips, 6-minute videos on different techniques and tips. The short stuff on GOA.com, some of it is about a third of the content on GOA.com is free, and 2/3 is behind a paywall. And there's quite a bit of stuff on YouTube as well. So I mean, if you Google my name, you'll find more junk than you know what to do. But don't be shy about emailing. If you have a question, that's fine. Or I wouldn't. If I didn't want you to do that, I wouldn't give you my email.
Any other questions? Now's the time, Jerry.
Things your daughter uses to eat.
It's the other isotopes. Extra with no E. Isotunes Extra is the other style.
Great. Great, thank you.
Well, George, on behalf of the group, we really, again, really appreciate you coming out.
Well, I'm glad it worked out.